Assalamualaikum and hi. We from group 5 and in this video we would like to present about the hydraulic jump. Firstly, I would like to introduce our team members. I, Muhammad Fikrie bin Muhammad Puzi, is the leader of this group. And my fellow members is Muhammad Faiq bin Zamzam, Muhammad Naim bin Wazir, Nurin Nadiah binti Azhar and Izzah binti Shamsuri. Next, we're going to tell you about what is hydraulic jump.
Hello everyone. For today we are learning about hydraulic jump. So what is hydraulic jump? A hydraulic jump is a sudden transition from a supercritical open channel flow regime to the subcritical flow motion that usually seen below weirs and sluice gates where a smooth stream of water suddenly rains at a forming front. So, hydraulic jump are commonly experienced in river and canals, in industrial applications and manufacturing process, as well as in the kitchen sink too. So, how hydraulic jump happen? The hydraulic jump phenomena that occur in the sink happen when a jet of water descends vertically from a tap onto the base of the residential sink. The water spreads in a thin film radially outwards until it reaches a radius where the film thickness varies, and the fact that the speed of the water wave varies with the wavelength and with the amplitude leads to wide variety of effects. The characteristic of hydraulic jump is hydraulic jump helps to dissipate the excess energy of the water flowing over the spillway of the hydraulic dams and also help to increase the weight on one apron of the hydraulic structure due to the increase in the depth of flow. Hence, the uplift pressure on the apron is quite unbalanced. It is used to remove air pockets from the wave supply pipes and also use the aeration and dechlorination of aeration. Next, let's talk about theory of hydraulic jump. The circular hydraulic leap refers to this sudden shift in depth. On vertical and sloping surface, a similar phenomenon occurs in which the liquid layer extends radially outwards before creating a jump. All available hypotheses attribute the origin of the hydraulic jump to gravity, meaning that the jump site should be responsive to surface orientation. However, we can discover that under the identical flow circumstance, normal impingement of liquid jet produce a circular hydraulic leap with the same starting radius regardless of surface orientation. In theory, a flow must be in the supercritical range where the Froude number, which is NF, describes critical flow. So, as you can see, here is the formula where U is the fluid velocity, G is the acceleration of gravity, Y is the depth of the fluid stream. If NF equals to 1, the flow is considered as critical. If NF is lesser than 1, the flow is considered as subcritical. And lastly, if NF is more than 1, the flow is considered as supercritical.
This is some example of how hydraulic jump happen in the sink.
What is the critical speed? The critical speed is determined by a quantity. It's called the Froude number. The Froude number is Fr is a ratio of speeds. Fr is equal to characteristic flow speed over gravitational wave speed. We go to the result. When the condition Fr is bigger than 1, it's called supercritical flow. In the inner region, the flow is rapid and the water is shallow, so the wave speed is small, making the Froude number large. And when outside the jump there is a deeper water and the flow speed is less, so we have Fr less than 1, a condition called subcritical flow. Thus, there is a transition from supercritical to subcritical flow across the jump. At the critical radius where Fr is equal to 1, a circular lip appears and the depth may increase by an order of magnitude. We move to how the circle in the sink can exist. That the circle in the sink is depending on how fast water flows. It is faster or slower than waves that propagate on it. In the circle around the point of impact, the water shoots, so all disturbances or waves are simply washed away and cannot spread. The water looks smooth. Only at the hydraulic jump, the water has become so slow that behavior of the flow changes. The water level rises abruptly and the water only flows rather than shoots. Waves can move freely in all directions and the water therefore looks much more irregular.
There is possible to make a hydraulic jump with liquids other than water? Yes, it's possible to make a hydraulic jump with liquid other than water. When liquid flow along an open channel at high velocity, the flow can become unstable and slight disturbances can cause the liquid upper surface to transition up totally to a high level. This sharp increase in the liquid level is called a hydraulic jump. The increase in the liquid level causes a reduction in the average flow velocity. As a result, potentially destructive fluid kinetic energy is dissipated as heat. Hydraulic jumps are purposely engineered into the large waterworks such as dam spillways to prevent damage and reduction erosion that could be caused by fast-moving streams. Hydraulic jumps also occur naturally in the river and stream and can be observed in household conditions such as the radial outflow of water from a faucet into a sink.
Hydraulic jump phenomena in the sink breakdown when the phenomenon is dependent upon the initial fluid speed. If the initial speed of the fluid is below the critical speed, then no jump is possible. For initial flow speeds which are not significantly above the critical speed, the transition appears as an undulating wave. As the initial flow speed increases further, the transition becomes more abrupt, until at high enough speeds, the transition front will break and curl back upon itself. When this happens, the jump can be accompanied by violent turbulence, a dying air entrainment, and surface undulation or waves.
For the conclusion, under the influence of a various flow structure, a hydraulic jump experiment was carried out in a rectangular open channel flume. Several experimental runs were complete in order to obtain Y2 by measuring Y1 and Q with a various flow structure and gate opening. The measured values of Y2 different from the simulated result of a previous equation. Furthermore, the measured Y2 varies by varying the flow structure for the same Y1 and Q, indicating that the former hydraulic jump equation should be modified to account for the impact of shear force due to the friction between hydraulic jump and the bed of a water canal. And this is the end of our presentation video. If you have any question, you can personally message me. And thank you for today. See you again next time. Thank you.